Okay, ma'am.
Okay. So today I will start inventory. I've already discussed inventory cost or cost associated with the inventories in the previous class. And these costs were setup cost, if you could remember, setup cost, ordering cost, purchase cost, carrying cost, and shortage cost. Each type of cost I've already told you in the previous class. So now I will dictate some factors affecting the inventory control, and these factors are very important. We can otherwise say these are the important terms in inventory control. So these terms are, let's say, let me give you the heading as factors affecting inventory control. First one is the demand. That everybody knows, demand is the most important thing for any enterprise. Demand is nothing but the number of units required per period. Okay. Number two is the lead time. These terms you already know. Lead time, in the previous class also I have told you, lead time is denoted by, mostly I use the symbol LT, capital LT, for the lead time. It is the time gap. It is the time gap between placing an order and between and receiving it, between placing an order and receiving it. Receiving it is our lead time. Okay. Then third is the order cycle, order cycle. This is the time period between placement of placement of two successive orders. Okay. Fourth one is our reorder level. Reorder level. The level between maximum and minimum stock. Minimum stock at which purchasing activities purchasing activities must start for replenishment. These terms will be very much clear to you when we work out the problems. Okay, so these are the terms. You should be very much acquainted with these terms. And now I will start the basic EOQ model. Basic EOQ means economic order quantity. EOQ model. This is the simplest one. In this we have so many assumptions. Okay, so your x-axis is the number of units. Number of units. and this is the cost, y axis. And next, as I've told you, there are so many costs, like ordering cost is denoted by CO. So let's say this is the ordering cost. Let's say this is the ordering cost. Okay. Then inventory carrying cost. Let's say it is the straight line. This is the that ordering cost is the cost associated with ordering of raw materials. It may be including some spare parts, maybe some advertisement consumption. You can see that, suppose let's say ordering cost is the cost of raw material. You can see from the graph that if you order more number of quantities, if your quantities are more, your price is reduced, isn't it? So initially for low number of quantities, your cost is high. That is usual. We know that when you purchase something in bulk, your quantity used to be less. This is the ordering cost. Inventory carrying cost, carrying cost is it is a cost associated with carrying the inventory. And it is directly proportional, so it is very straight. When even if you purchase more number of even if you have more number of inventory, it is directly proportional to the number of quantities, because more space, more inventory items are there, means more space you will be needing, so it's a straight line. So this is the ordering cost and this is the carrying cost. Carrying cost is also known as your holding cost. Inventory carrying cost. Now comes the total cost. Total cost, why? Total cost will be the summation of different costs. So, so total cost is, let's say, this is the total cost. Okay, this is the total cost. Why I'm drawing this thing is that you will get the EOQ. EOQ is nothing but economic order quantity. What is the minimum order quantity? That in the previous MRP problems, if you could remember that we had done order quantities 400, order quantities 300. That means at a time we were ordering 200, 300, 400 for any subpart. Its amount was fixed. That time you didn't know how to calculate that economic order quantity. So in this chapter you will learn how to calculate the order quantity, economic order quantity. Okay, we should neither order too much, nor we should order too less, isn't it? So the economic order quantity will say how much quantity at a time we should order. Okay, so this is the point. It is the number of units. This is your EOQ. From the total cost only, this is the total cost. We can estimate this is the total cost. And how total cost, what is the formula for total cost, how total cost is calculated, that everything I will show in this derivation. Okay, this is the EOQ, and at EOQ you can see that at EOQ you will have the minimum cost, minimum total cost. At EOQ level you have minimum total cost. You can see cost, your total cost is minimum at this curve, at this point. Okay. You can see that minimum total cost occurs at the point where the ordering cost and the inventory carrying cost meets, or it is equal. Okay, you can see that at this point it is the minimum total cost. So at this point you can see that minimum total cost occurs at the point where the ordering cost where the ordering cost and inventory carrying cost and inventory carrying costs meet and are equal and they meet at the point. That is the total, that is the minimum total cost. So, so in this basic EOQ model, there are assumptions, because in business nothing is fixed, but in order to calculate something, you need to assume something. Assumptions. What is the first assumption? Number one, demand. We know what is the demand, and it is uniform. You have, if you have remembered the problem that we worked out for materials requirement planning problems, you could see that demand was given to you, demand was fixed, you know the demand, and it was uniform. uh, Uniform means up to for 1 week. Okay, for 1 week it was known. And so in this case, assumptions, first assumptions what we are taking, demand. Demand is denoted by capital D. Demand D is known and uniform, that it is not going to change. This is the first assumption we are taking. But actually what happens, demand used to change. But we cannot every time, if we consider the change in demand, we cannot achieve to a certain point. So we assume that demand is known or uniform. That means there is little bit variation of demand. That's why we are assuming it to be uniform. Okay. Next, production or supply of parts or subparts, or supply of commodity, or commodity means parts or subparts, is instantaneous. Is instantaneous. Okay. Number three, ordering cost. Then number three, shortages are not permitted. That means shortages are not permitted. Means as soon as the level of inventory reaches zero, the inventory is again replenished. But that means inventory is never zero. That means when we see that inventory is going to be zero in the coming week, before that we have to give order and get the stock. So that is the thing, that shortages are never not permitted. Number fourth, the ordering cost per order CO. I've already used the symbol CO. This is the ordering cost per order. If you have more number of orders, you have to in order to get the total ordering cost, you have to multiply by number. So that's it. Is fixed. Is fixed. Ordering cost per order is fixed, irrespective of lot size. Usually what happens, irrespective of lot size, if you have ordered for more quantities, means there is a quantity discount. But in case we are assuming that in the basic EOQ model, we are assuming that ordering cost per order is fixed irrespective of lot size. That means whatever may be the order quantity. Number 5, setup cost per production run. Production run denoted by CS. CS, okay, is denoted by CS. That means setup cost is denoted by your CS. And you know that what is the setup cost? It is a cost associated with setting up of machinery even before production. So it is independent of the number of quantity orders. I've told you in the previous class that it is the cost of setting that all the machines are in good condition so that it can work when properly. This is the setup cost. Then Q is the order size. Q, capital Q is the order size, order size in each production run, in each production run, and lead time, seventh one, lead time, that is LT. LT for deliveries is constant and known. We know the lead time and known with certainty. Capital P is the purchase price per unit. Purchase price of subparts. Purchase price per unit. Okay. So for that, suppose we draw earlier we have drawn a cost versus EOQ. Now Q versus time we are drawing this curve. Q is the order size in each production run and T here is the time. That is inventory. This is y axis is our inventory versus time. Okay. So this Q I'll write down here. So we are assuming that Q is our constant. So that's why this is a basic EOQ model. This all are equispaced. Here to here same space, here to here same space, here to here it should be same space. T T T. And this is our quantity Q. Inventory quantity Q, that is our order size. Every time it is Q. And this is average inventory. Average inventory. And at this point it is intersecting. So up to this much, this distance is our lead time. This is lead time in all the cases. This is the lead time. And this is the total time T. This is the time T. Now we will derive the equations for economic order quantity as well as the total cost. So we have already taken, let Q is the order size. We've already taken assumption, let Q is the order size. D is the annual demand. I've already told you annual demand. So therefore number of orders per year. First formula, number 1. Number of orders per year. D is the annual demand. So it will be obviously D by Q, isn't it? Yes. Okay. So this is the first formula. You can make it in a box also. Number of orders per year. You can see. Let's say this is equation number 1. Then ordering cost per year. Ordering cost per year. What is ordering cost per order? You can see that ordering cost per order is your CO. So for I've told you ordering cost per order is CO, and for number of orders D by Q it will be D by Q into CO. This is the total ordering cost annually. Okay. So let's say this is equation number 2. Then carrying cost per year. Carrying cost per year. Okay. What is the symbol for carrying cost? Have we taken carrying cost? Here we have not assumed, but you know that carrying cost is your CC. I've told you carrying cost is associated with carrying the inventory. See, so it is your CC depends upon the average inventory. Average inventory, that is average order size, that is your Q by 2. So it is carrying cost. So it will be CC into total carrying cost will be average inventory it is equal to your Q by 2. Carrying cost deals with your carrying the inventory cost. So it is per year if we are taking this Q by 2. So it is your equation number 3. Now purchase cost per year. Purchase cost per year. I've told you in the previous class purchase cost per unit is I've taken here. Yes, in the previous class also I have told you, and capital P, the purchase price per unit. Purchase price per unit is P, and for demand it is equal to total number of demand. It will be your total cost will be your P into D. So total purchase cost per year is P into D. So let's say this is equation number 4. Now we will go to the total cost. Total inventory cost per year. Okay. Total inventory cost per year, that is your TC. It is equal to ordering cost per year plus carrying cost per year. That means equation 2, 3, 4 plus purchase cost per year. Okay. So you can write total inventory cost TC is equal to, you know that ordering it is equal to your C0 D by Q plus CC Q by 2 plus P into D. So this is, make it in a box, total inventory carrying cost. If it is given, even in, you have to work out this in terms of quantity discount. You have to determine the total cost. That time you have to remember this formula. So you can see that a number of orders per year, total cost, purchase cost, ordering cost, everything, carrying cost, everything is there. So this equation, maybe this is equation number 5. but our main aim is we want to determine the economic order quantity. Okay, this is equation 5, we got it. Now differentiate it. Differentiating with respect to Q. Okay, now d by Tc with respect to dq is equal to 0. Okay, so it will be minus d by q square, isn't it, into CO being a constant, plus Cc by 2. So here it will be nothing else, 0 is equal to 0. Finally, you will get that implies q square is equal to 2d C0 by Cc, that implies Q. I'm giving Q star because this is the economic order quantity, EOQ. This is our EOQ. 2D, this is the formula you should remember, and directly you'll put the formula and calculate the EOQ. So this is our EOQ derivation. Economic order quantity. By this only we can determine the EOQ. Economic order quantity. This is the EOQ or optimum Q, or optimum Q. Okay, and another thing I would like to tell you regarding carrying cost. Carrying cost is your CC. Sometimes CC is not given directly. That time CC is equal to I into P. In some books, instead of I, it is a capital I, it is small I is given. You can get it. Where P, you know, it is the unit cost or the purchase price per unit. Purchase price per unit. Okay, and I, capital I, if you are using small I also no issue. Small I, inventory carrying cost, inventory carrying cost. It will be given in the question, cost expressed as a percentage of inventory, average value of inventory. Percentage of value of inventory. If you wish, you can use small I also or capital I also. So this is the question, and now I will work out one problem. Suppose the problem is dealing with this. This is the question. ABC company estimates that it will sell 12,000 units. 12,000 units of its products for the forthcoming year. The ordering cost is rupees 100 per order, and the carrying cost is per year is 20% of the purchase price per unit. The purchase price per unit is rupees 50. You have to find number 1, find economic order quantity. Number 2, number of orders per year. Number 3, time between successive orders. So now we will work out the problem. So before starting the problem, first we should note down what are the given data. What is the demand? D in this case is our 12,000 units per year. Then ordering cost is given CO. Ordering cost denoted by CO is rupees 100 per order. Then carrying cost per year is 20% of the purchase price. So that means your I is equal to 20%. I is equal to 20%, that means is equal to 0.2. And carrying cost is this much of the purchase price, and purchase price per unit, that means capital P is rupees 50 per unit. Okay. Now from these two data we can calculate CC. So CC will be 0.2 into 50. So it is rupees 10 per unit per year. Now we get D, CO and CC. Now I think now we can compute. This was the simplest EOQ problem. EOQ is equal to EOQ, or we can write down Q star also, whatever you feel. Star means star symbol we are giving for economic order quantity. It is equal to 2D C0 by CC square root. So it is equal to 2 into 12,000 into CO is ordering cost is 100 by this is 10 square root. If you work out this thing, it will be coming around 490 units. So we got our EOQ, economic order quantity, is 490 units. Every time we will be going for 490 units. Second bit is number of orders per year. It is equal to D by Q. Here in this it is Q star. So demand is your 12,000 and divided by Q star is equal to 490. So it will be coming around 24 number of orders per year, 24 numbers. Third one is your time between successive orders. Time between successive orders. That is equal to just reciprocal of this. Q star by D, it is equal to 490 divided by 12,000. It is equal to around 0.04 year. If you convert it into month, it will be around 0.48 months. So this was all about your simple EOQ model.